In this lesson, we will continue to talk about solving a system of equations, but this time you will learn about another method called the elimination method. Let's take a look at some notes and examples to better understand this concept. Elimination method part 1. In this lesson, we're going to solve a system of equations using the elimination method. You should have already learned how to solve a system using graphing as well as the substitution method. So this is simply a third method that can be used that many find easier depending on the format of the equations given. So let's take a look at example 1. When using the elimination method, we want to look and see if the two equations that are given are both in standard form. If they are, then it's actually easiest to use the elimination method. Now, what I mean by standard form is if the x and the y in each equation are both on the left, then it's typically easiest to use this method, although this method can be used no matter what the format of the equations are that are given. So what you do to see if you can use the elimination method is you look to see if you can eliminate one of the two variables, either the x or the y. To do this, you want to look at the coefficients of the x's and then the coefficients of the y's. So as long as they're set up with the x's and y's on the left side of the equal sign lined up like they are with these two equations, here's the x's and here's the y's, we can actually add these two equations vertically. So let's go ahead and do this. We're going to first add the 2x and the 3x, which is 5x. And then we can add 4y and negative 4y, which is 0. Now we do not need to write the 0. We can simply eliminate the y, which is why this is called the elimination method. Because if one of the variables can be eliminated using addition, then we can go ahead and do this process. So we can continue and we can add the 8 and the 2, which is 10. So notice we only have one variable left as we go through this process. So we will now solve for that variable. So x equals 2. So we have found half of our answer, just the x. Now once we do this, just like the elimination method, just like the substitution method, we can now pick one of the two original equations and plug 2 in for x and then solve for y. So looking back at the two original equations, just pick one of the two. I will go ahead and pick the first equation, 2x plus 4y equals 8. Because we know that x equals 2, we can replace the x with 2. So it will be 2 times 2 plus 4y equals 8. We then have 4 plus 4y equals 8. We will subtract 4, so we have 4y equals 4. And when we divide 4, y equals 1. So y is 1 in our ordered pair, which is our solution. So just to look back at the beginning, again, if your two equations are in standard form, where the x's and the y's are lined up on the left side of the equal sign, you can go ahead and add them as long as the coefficients of one of the two variables, in this case the coefficients of y, when you add them equals 0. If they do not, then you would have to do an additional step to use this process, which you will learn about in a future video. But for this lesson, we're going to focus on identifying which variable, if you were to add them together, would be able to be eliminated. Now that we've found our solution, we want to prove our solution. Now we could do this by graphing, which we've done in a previous lesson, or we can do this by simply plugging in our solution into both equations and make sure they work. So in this lesson, we're going to focus in on plugging our solution back into the equations to double check our answer. So remembering that our solution is 2, 1, we're going to scroll down and I'll show you how to prove our solution. Let's rewrite our solution of 2, 1. And now I'm going to show you how to prove that we are correct. What you need to do is we know that x is 2 and y is 1. So we're going to plug both of those values back into our equations and make sure that they work. So let's focus on the first equation. 2x plus 4y equals 8. Because we now know that x is 2 and y is 1, we can replace the x with 2 and replace the y with 1 in our equation. We will now simplify the left side of the equation. The right side is already simplified, as we can see that it's 8. So we get 4 plus 4, which equals 8. Now let's drop down the right side of the equal sign. Now as long as the left and right side are equal, then so far our solution proves to be valid. But it has to work in both equations, not just one. So you always want to try both. So our second equation, 3x minus 4y equals 2. We can now plug in the values of x and y to this equation as well. So 3 times 2 minus 4 times 1 equals 2. If we simplify the left side of the equation, we get 6 minus 4, which equals 2. So dropping down the right side, again, notice the left and right side are equal. So we have now confirmed that the solution 2 positive 1 is in fact the point of intersection or solution for this system of equations. Now for some of you, it's very easy to visually do this without having to do all this work. You can simply visually plug in a 2 here, plug in a 1 here, and then just calculate that in your mind and make sure that it equals 8 in the first equation. Then do the same thing in the second. Substitute in 2 and multiply it by 3. Substitute in the 1 and multiply it by 4, and subtract those numbers and make sure it comes out to 2. And that is one way to double check your answer aside from graphing the equations, which would take you quite a bit longer. Let's now take a look at a second example. If you look at the second example, you can see that the second equation is not in standard form. Now by standard form, the one rule that you do not have to worry about is that the coefficient of x does not have to be positive. The main thing is you just want to line up your x's and y's for the two equations. So in the second equation, we want to rearrange this so the x and y are both on the left side of the equal sign. So in order to move the x to the left, we would need to subtract it from the right to move it over to the left. So x minus x is 0, removing it from the right. And on the left side, we have negative x plus y equals 2. So our second equation now looks like this. We can then drop down the first equation, and you can see that the x's and y's are lined up on the left, and our constants, which are the numbers with no variables, are lined up on the right. So now we are allowed to go ahead and add as long as either the coefficients of the x's or the coefficients of the y's add up to 0, which would allow us to eliminate a variable. So notice the coefficients of x do add up to 0, negative 1x plus 1x, so we can eliminate the y. Then we will add the remaining terms. So starting with the y's, we have 1y plus 4y, which is 5y. On the right side of the equal sign, 2 plus 23 is 25. So if we then divide by 5, our value of y is 5, which would be half of our answer. Let's go ahead and draw a line to give us some room to find the value of x. Now I would go back all the way to the original two equations and look at that second equation that solved for y. That would be the easiest equation to use if we're plugging y back into the equation. So y equals x plus 2. We can replace the y with 5 and then simply solve for x. So to do that, we would subtract 2 from both sides of the equal sign, and x would equal 3. So our solution should be 3, 5. Now you may be able to visually plug those numbers in for the x and y and simplify the left side of the equal sign in your head and see if you get an answer of 23. You would then do the same for the second equation. But I'm going to go ahead and scroll down and go through this process in case you aren't able to visually see it. Again, let's remember we want our answer to be 3, 5. So to double check, we're going to plug in those values for x and y in both equations one at a time. Our first equation, x plus 4y equals 23. We will replace the x with 3 and the y with 5. We will simplify the left side of the equal sign. So we have 3 plus 20, or 23. Drop down the right side and make sure they come out equal, which the first one does. So now let's check the second one. Y equals x plus 2. Y is 5. X is 3. In this equation, we will simplify the right side, which is 5, then drop down the left side, and again, they're equal. So we can be confident that our solution of 3, 5 is in fact the point of intersection if we were to graph these two equations. Let's take a look at our last example. In this last example, you will notice that the second equation has a fraction. The first equation is already set up with the x and the y on the left side of the equal sign. The second equation is not, and it has a fraction. So you probably want to first clear the fraction by multiplying all terms by 5. This would give you 5y. Let's back up and multiply every term by 3. So this would give us 3y equals negative 5x minus 3. We then want to rearrange the equation and move the negative 5x to the left by adding it. This would eliminate the x from the right side, moving it over to the left. So putting the terms in alphabetical order, we would have 5x plus 3y equals negative 3. Now we can drop down our first equation. Doesn't matter the order that you write them in. And then we want to see if the coefficients of either the x or the y, if we were to add them together, would be eliminated. And you can see that the x terms would be eliminated because 5x plus negative 5x is 0. So now we can add the remaining like terms. So we would have 6y equals 3. We could then divide both sides by 6. We would have to reduce 3/6 to lowest terms, which would be 1/2. And that will be the y value of our answer. I will now scroll down so that I have a little bit of room to plug in 1/2 into one of the original equations for y so we can find the value of x. I will now replace the y with 1/2 in the first equation. So now we can solve for x. So we have negative 5x plus 3/2 equals 6. Now again, if you feel more comfortable and want to clear the fraction, you can multiply all the terms by 2. So this would give you negative 10x plus 3 equals 12. From here, to solve for x, you would subtract 3. So you would have negative 10x equals 9. And then divide negative 10. So x equals negative 9/10. So our solution would be negative 9/10 for x and 1/2 for y. And if you were to graph your two equations, that would be their point of intersection. Now, we can go ahead and go through the process of double checking this by plugging in those values. To double check our solution, let's go ahead and plug -9/10 for x and 1/2 for y into the first equation. So we have -5 times the x value of -9/10 plus 3 times 1/2 equals 6. So we want to simplify the left side of the equal sign and see if it equals 6. So -5 times -9/10, we can cross cancel the 5 and the 12, leaving us with 2 in the denominator and 1 in the numerator. So now when we multiply, it's simply -1 times -9/2, which would be a positive 9/2. Here we have 3/1 times 1/2. And when we multiply those, we get 3/2. If we continue to add these by adding the numerators because they have common denominators, we would get 12/2. And if we divide that, we get 6. So if we drop down the right side of the equal sign, you will see that they match. Let's now double check our second equation. So here in the second equation, the y can be replaced with 1/2, and the x can be replaced with -9/10. You can cross cancel in the second fraction here, or the second set of fractions, the 5 and the 10, and then the 3 and the 9. So we would have 1 and 2, and then we cross cancel the 3 and the 9, we'd have 1 and 3. So making it easier to multiply, we now have, when we multiply, -1/1, or just -1, times -3/2 would be a positive 3/2 minus 1. So 3/2 minus 1, if we make a common denominator, would be 3/2 minus 2/2, because 2/2, when you divide, equals 1. So when we subtract the numerators, we would get 1, and then we keep our denominator the same. So notice when we drop down the left side that they both equal 1/2. So we can be confident that our solution of -9/10 and 1/2 is the solution or point of intersection of our two equations. And this completes the lesson on solving a system of equations using the elimination method.